Welcome to SFAB. I am your host Nivedita, and today we have with us Hareesh Chandrasekar, who is the co-founder and COO of AGNIT Semiconductors. AGNIT is a deep tech startup started out of IISc Bangalore, where and it truly embodies the spirit of Make in India and Atmanirbhar Bharat. We would be talking with Hareesh about his startup journey as well as the rise of Indian semiconductor industry. Welcome, Hareesh, to this episode.
Thank you, Nivedita. It's a pleasure to be here and to address the viewers of SFAB.
Thank you so much. So let me start with the first question. Could you, for our audience, please explain what AGNIT is and what is its mission and how did you get started about it?
Sure. So AGNIT is a deep tech startup. We are based out of the Indian Institute of Science, Bangalore. We are a spin-off from IISc. And AGNIT primarily works on gallium nitride-based semiconductor components for electronics. So the reason that this is important is because, as the global shift to electricity is proceeding apace, what we actually need are more efficient electronics, which can actually transfer power, and who can convert power. So what do I mean by that? So let's take the example of a wireless base station, which is what supplies a cell phone with a signal, right? So if you think about what's going on there, you're transferring some power from the base station to your cell phone, right? So that's an example of a power transfer. And this sort of power transfer happens at a very high frequency. So your cell phones, for example, in 4G work at a few gigahertz, right? On the other hand, you also have things like mobile phones and laptops, right? So they all get charged. And they essentially, you convert an AC signal in terms of electricity into a DC signal that's stored into your battery. And this sort of power conversion also happens at lower frequencies, right? So your main frequency is 50 hertz in India, and probably the electronic component that is switching at a kilohertz or so. So this is power transfer at low frequency. And these applications are only going to increase in number as we go forward, as we go to a more connected world, as we go to a world which uses more electricity. So it's very important that these components be made as efficient as possible, because that will result in enormous amounts of power saving. Mm-hmm. So this is where gallium nitride actually comes into the picture. So gallium nitride is very useful for making very efficient switches and very efficient power amplifiers. So they're useful for lots of, any kind of power transfer at high frequency or low frequency. Gallium nitride is quite useful. Right? And this is what AGNIT does. So we work on electronic components based on a new semiconductor material for gallium nitride. So we can talk about why gallium nitride in a bit, I suppose. So the reason that we have actually started doing this is because we had been developing this technology at IISc for more than 15 years. And we have numerous patents, and the work has been published in many, many journal papers. And but of course, nothing gives you quite the kick as seeing your product out in the market, right? So that's what we decided to embark upon. So that's the reason that we are now on this technology commercialization journey. And this is what we hope to achieve with AGNIT. So we'd like to be a significant player in this gallium nitride-based market. And we do have the technology to do so. And it's a question of finding the right markets to put this technology into. So that's what we're working towards.
Awesome. So as I understand, like gallium nitride is one way to, like a new way to produce semiconductors. But previously in general, silicon has been known to be the way the semiconductor industry has progressed. And so, but now gallium nitride is touted as the way by which India can get into a foothold in the semiconductor industry, which it had previously missed around like 20-25 years when it was starting up. So can you please explain to our audience more about it, and why is it important for India right now to invest in the gallium nitride semiconductor industry?
Yeah, that's a great question. So we'll take it into two parts, right? So the first part being why gallium nitride, and the second part being why it might be a good idea for India to invest in gallium nitride. So in terms of why gallium nitride is a new material when compared to silicon. So apart from all the other applications that I just spoke about in terms of power conversion and power transfer, so all of these applications are enabled by the fact that gallium nitride has certain superior material properties. Mm-hmm. So if I were to just share my screen with you, so we can take a look at what those superior electronic properties actually mean in terms of an electronic application, right? So you can see my screen, right? Yeah. Okay. So let's just take this. This is a busy graph. So we'll just take it, from the top axis and just go clockwise.
Okay.
Right? So gallium nitride has, a very large band gap when compared to silicon. So the band gap of gallium nitride is 3.4 electron volts, and silicon is 1.1 electron volts. What that actually means is that it can block a larger voltage at the end of the day. Okay. So what this graph is telling you is that you can also use it in power supply circuits because gallium nitride can withstand a very high temperature when compared to silicon, right? So what is shown here on this graph is all the blue lines represent gallium nitride, all the the green lines represent gallium arsenide, which is the previous semiconductor technology or compound semiconductor technology of preference, and of course the gray lines represent silicon, right? So you can see that along most of these axes, gallium nitride is doing pretty well, and we'll talk about why. So one of the reasons is of course the fact that it has a very large band gap. So similarly, if you now move clockwise and go to this, gallium nitride has a very high maximum oscillation frequency, so which is very useful for this. Let's say we are talking about this 5G kind of applications, right? So where you need to switch power at higher frequencies, right? So the oscillation frequency of gallium nitride. Sorry.
Does gallium nitride also do 6G applications? Like
yes, 5G and beyond. Yeah, anytime you want to switch high amounts of power at higher frequency, gallium nitride is the solution of choice. You can see that gallium arsenide actually does better on this particular metric. And this is what actually goes into mobile phones themselves. But if you talk about what's going on at the base station, then it needs to supply a high amount of power just to get everybody's cell phone a signal, right? So that's the reason that gallium nitride is very useful in this particular case. And this is because it has a very high, field saturation speed, or you can say saturation velocity. Just think about it as the speed at which carriers can move in gallium nitride, right? So electrons move at a particular pace in gallium nitride, which is faster than silicon. So similarly, it's also advantageous in RF circuits, mainly because of the superior noise factor. And this is because, again, the mobility is very high. So you have very low amounts of scattering in this particular material. So again, the advantage for power supply circuits is, again, the fact that gallium nitride has very high carrier density and it has a very high mobility, like we've been talking about. So again, this is extremely advantageous because then you can supply a high amount of current. At the end of the day, a switch needs to conduct a lot when it's on, and it needs to block a high voltage when it's off. So this part addresses the conduction issue. So which means that gallium nitride can switch very high currents. So similarly, again, the fact that you have very high breakdown strength is due to the fact that gallium nitride has a large band gap. So this is the off state of the switch now. So we were talking about the on state earlier. This is the off state. So it can block a very high voltage, right? So due to all of these advantages, gallium nitride is probably a superior material, at least for doing any kind of power transfer or power conversion, high power transfer and high power conversion, whether it's at high frequency or at low frequency.
Could we, for our audience, explain like when gallium nitride was first innovated? Because silicon is generally found in our is a natural material, versus gallium nitride was specifically made. Could you tell a little bit of history of that?
Sure, it's an interesting story because actually the 2014 Nobel Prize in Physics was awarded to gallium nitride, and this is primarily for white LEDs. So gallium nitride comes from that world. It comes from the optoelectronics world, the LED world. If you remember 20 years back, all the the indicator switches on all of these electronics panels would all be red LEDs, right? And they were all based on gallium arsenide. You wouldn't see any other color. So interestingly, so the quest for gallium nitride comes about because people wanted to make more efficient white lights. And to make white, you have to combine red, green, and blue. So you have to look for the right kind of band gap that gives you the green as well as the blue emission, because the red already existed in the form of gallium arsenide. So that's where the whole quest for gallium nitride started, and most of the work was carried out in the late 1980s to early 1990s, and that's when the technology was very, very underdeveloped. And the three Japanese researchers who won the Nobel Prize in Physics, they all made tremendous contributions, Amano, Akasaki, and Nakamura, to GaN LED fabrication, especially growth, which was a big issue. Because as you pointed out, gallium nitride does not grow naturally, and it has to be made. So people knew that it could be made, but to be made in the same quality that you require, for this to be a manufacturable process, for this to be used over and over again, is quite a different feat. And so that's where the whole thing started out. And it turns out that some of the same properties, for example, the band gap of 3.4 is what enables you to make blue LEDs. But it's also advantageous in electronic circuits because it can block a high voltage or can be used at high temperatures. Right? So that's where the history of gallium nitride probably comes from the optoelectronics world.
Times there are like inventions which are done for a particular application or space, and then eventually over time it leads to something.
Yeah, absolutely. Absolutely.
That case. Yeah.
Absolutely, it totally fits that bill, and the fact that people could also start having these high carrier densities and low, extremely good carrier mobilities in gallium nitride for certain structures means that it was really taken up by the electronics industry in a big way. It's starting to permeate the markets as we speak. So yeah, it's one of those serendipitous discoveries, which was, which came from the optoelectronics world and is also equally applicable in electronics. And it's probably, it's quickly becoming probably the second most important semiconductor after silicon.
Very interesting.
So it does have its applications, yeah.
So now the second part of the question is like, why should India be getting gallium nitride?
Yeah, this is a very important question. So I would think about it along three axes. Okay, so let's in terms of complexity, competence, and cost. So what do I mean by that? So let's talk about complexity. So in terms of complexity, if you were to make, let's say, silicon-based CMOS circuits at the 7 nanometer node, which is extremely hard to do, and which many companies world over are struggling to do, and few of them, of course, do it. Right? TSMC does it, for example. So this is probably the highest amount of complexity that you can actually make in any kind of semiconductor manufacturing process. Right? And okay, so now let's slide down all the way to the other end of the scale, right? So let's take a look at if you can make polysilicon, which is used in solar cells. Right?
Yeah.
So at this stage, it's a commodity product, which many people can make, right? And then you are competing on cost at the end of the day, right? So that's at the very other end of the scale, right? So which is very important, especially given the offtake in terms of solar cells world over. But it's a commodity product as far as semiconductor manufacturing is concerned, right? And gallium nitride would be some kind of a sweet spot. It's not as complex as making, the cutting edge silicon CMOS circuits, but it's not a commodity in the sense that you do need some kind of specialized expertise. So it could be somewhere in the middle of the scale, which is a very nice place to be. So the other thing is, let's talk about competence. So in terms of competence, gallium nitride is up and coming technology, and people have been working with it in terms of making LEDs, etc. And even in India itself, we have a very strong research base in gallium nitride. So there are many research groups in ISC, in IIT Bombay, in IIT Madras, IIT Delhi, IIT Kanpur, and many other places. So there is already an established research base India-wide as well as worldwide, of course, working on gallium nitride. Right. So we do have the competence, and more importantly, there is an ecosystem, a very strong design ecosystem in India for radio frequency electronics and for power electronics. So which means that there is a natural fit in terms of offtake of components, right? Which can be designed into systems and circuits, right? Which is what you want at the end of the day. So in that sense, it's a pretty nice place to be in, right? Gallium nitride is a nice place to work on. And in terms of cost, so if you talk about the cost of putting up a silicon fab, we've all heard this number, right? So it's a few $1 billion, right? And whereas gallium nitride, you can actually put up a meaningfully sized fab for maybe $200 to $400 million or so. Right? So you could put up 5 or 6 gallium nitride fabs for the same cost as a silicon CMOS, cutting edge silicon CMOS. Right? And this is also important because if you do have limited resources, then it's a question of where do you choose to allocate them. And gallium nitride might be, in view of the impact that gallium nitride is going to have over the next 20 years, and the fact that it's, we do have some natural advantages in working with this technology here, it might not be such a bad idea to actually spend the money and set up gallium nitride based fabs. And of course, for a country of our size, we shouldn't have to make a choice between silicon based and gallium nitride based fabs. We need them all. Right?
Yes.
But this is my short pitch to your viewers about a gallium nitride.
Yeah. But you said like generally fabrication takes like 200, 300 like facility. So let's start by like telling us about how did AGNIT get started, and what's the story behind this awesome entrepreneur effort.
Okay, I seem to have lost you.
Yes, there is a.
Hello.
Is it my network? Hello. Hey.
Hi, sorry, I got knocked out.
Yeah, no worries. So I was asking about the story of how AGNIT got started, and like you were mentioning about the gallium nitride fabrication facilities requiring 200 to 300 million. So even before you raise money like that, let's get started about like how did this idea of like let's now convert this research effort into an entrepreneurial effort. Could you just tell us a story behind it, as well as I know there are like 6 other professors involved in AGNIT. So how did all this come about?
Right. I think the credit should be given to them for starting out in the first place. So, I think that at IISc, there's a very strong interdisciplinary group of scientists and technologists who've been working on gallium nitride for many years now, so more than 15 years now. And I think that the motivation came about because we do want to see our country do well in semiconductor manufacturing and semiconductor design. So to some extent in semiconductor design, this is already, you can take a look at the amount of offshore design centers which have been set up in India. But unfortunately, we've not been able to make a mark yet in terms of the semiconductor manufacturing. And for all the reasons that we've just spoken about, gallium nitride might be a good vehicle to do this. Right. So, that's where the motivation came from. And so that is the reason that in 2015, IISc was funded by NITI Aayog to write a detailed project report on setting up a gallium nitride foundry in the country. And that's the genesis of this whole thing. So, so there was a team at the Center for Nanoscience and Engineering, which got this grant, which was headed by Professor Srinivasan Raghavan. And we came up with, and I was lucky enough to be a part of that team. So I had just finished my PhD and I was hanging around before I went off to do a postdoc. And so it was a very exciting initiative to be a part of. So we wrote up this proposal and we submitted it to the government of India, to the Ministry of Electronics and Information Technology. And so they considered it at various levels, and it was discussed at the very highest levels of government. And eventually, so in 2021, which is last year, so we actually got a grant from the government of India. IISc got a grant from the government of India to set up a gallium nitride ecosystem enabling center and incubator. So this is also mentioned during question hour at Parliament. So this is where the, you spoke about the money that's required to set up a fab. We were talking about $200-300 billion. While this is not a $200 or $300 billion fab, it's a pretty sizable grant to set up a pilot production line, even to validate the fact that technology can be made and it can be proven in the field. Right? So, and it's also set up as an incubator, so that startups like AGNIT and any other startups which work on gallium nitride technology can actually come in and be incubated here without having to raise their own money and try to make a fab of their own. Right? So, which really de-risks the amount of capital expenditure you need. So that is the concept behind that. So we're all tremendously grateful for the fact that we did get this money, so that it does kind of accelerate the kind of technology development that we can do. Right. So that's how things got started. And in terms of AGNIT itself, we decided to start the company, and we started off last year in 2021. And our primary interest is to try and see if we can take some of these technologies to the market. So we have a platform now in terms of having this incubator, gallium nitride ecosystem enabling center and incubator. So as the name also indicates, it's also meant to develop an ecosystem and to see if products based on gallium nitride can actually be put into the real world. Right. So that's what we're working on. And that's also the genesis for AGNIT. So it all started back in 2015.
Find the ecosystem. So there are people like you who would be like fabricating the devices, like who all other players are there?
So in terms of the ecosystem itself, there are a lot of, as I said, the design ecosystem in India is quite mature and it's very good. So there are a lot of players, both private as well as government, who want to offtake some of these components that we do put in. So that's the ecosystem for you. So because at the end of the day, there needs to be a pull from people who will use these devices so that we can make the right kind of devices which are needed for them. Right. So that's where we're at. In terms of the ecosystem, I should also point out ecosystem also includes lots of other things. It includes things like support structure. So you need, let's say, raw materials and consumables. You need the tools that you're working on, to actually come in. So the semiconductor ecosystem is really huge, and it's pretty vast, and it's pretty interconnected, and it's pretty global, right? So it will take some time to set up all of that in India, but we've decided to make a start in terms of gallium nitride, making gallium nitride based electronic components. So to be very specific, so that's what we want to do, and the ecosystem will have to be built up around it as we go forward. So that's something that people are actively working on. Yeah.
Can you tell us some of the products, or like I would say transistors right now, which you have been specifically working on, and like when do you plan to launch it? Is there something near term? Yeah.
Sure. So we primarily have two products that we are working on. One of which is a gallium nitride based power amplifier, mainly for 5G base stations. So there is a lot of demand from 5G base station makers, and the radio unit, which is used in 5G base stations, which is what gives your cell phone a signal at the end of the day. The power amplifier, which is a very important component of that, is made of gallium nitride. So there is quite some demand from players who are looking to get into the 5G, the radio access network space. So that's one product, and the other product is more on the power switching side, and it's mainly a product for onboard EV chargers. So
Right.
onboard EV chargers need to be very compact, and they do need to, most of the electronics are then integrated into the vehicle itself. So which means that you could literally, kind of pull a plug out of the EV and just put it into any plug point and charge it.
Yeah.
So that you don't need additional electronics off the vehicle. So that's another place where gallium nitride's advantages come to the fore, because you can make very, very compact but efficient and fast charging circuits made of gallium nitride. So these are the two things that we are currently working on. We hope to have prototypes in the market in about 24 months. So this will have to be field tested extensively, and after that we can hope to actually start, seeing our products and systems, which is the hope.
So could you tell us like some of the challenges which you have faced till now in the last, like since you started?
Sure. I think in terms of startup, every startup needs talent and money, and
learning as well.
right. So and of course you do need to keep the books in order, and you need to keep the lights on, so to speak, right? So this is a challenge that every startup faces, and we are no different. So in terms of the talent, we have to say that there is a lot of semiconductor talent in India, and if you take a look at what's going on around the world, the semiconductor talent in India just leaves India and goes elsewhere. Right. So it's not very easy to have them, to retain them in India, and there's only so much that you can do as a startup, right? But we've been very excited to put together our team. So right now we have a team of 2 PhDs and 3 MTechs who are working with us, and this is a team that develops technology on the ground. And we're extremely proud of the fact that we could put together this team, and they're doing phenomenal work. So so we hope that we'll also expand the team coming soon, and so that's going to be the most key in order to even realize what we want to do, right? So hanging on to
the interview after this, like some of them get excited about gallium nitride and AGNIT and like want to.
Oh yeah, I really hope so. So because we are always looking for the best talent. So please do contact me if you if you work on semiconductors, and yeah, we can take it forward.
I wanted to talk.
So in terms, yeah.
Sorry, go ahead.
Yeah. No, the second part, of course, was the money. So AGNIT is we got incubated at IISc. So we put in some of our own money to start out with. We received a generous incubation grant and support, in-kind support from IISc in terms of use of facilities, etc. And we also have managed to raise angel funding, so which is what is keeping us going at the moment. So that's where we are in terms of the funding situation. And of course, there are a lot of initiatives that the government has announced, whether it's in terms of production-linked incentives or design-linked incentives. So these are all schemes that we expect to be applying for, so that the money can come.
Awesome. I think like there is like, slowly this change is happening, and you can just like see, and I can see that AGNIT is like literally in the forefront of it. So I do want to congratulate you as well as like your whole team for inspiring like the whole generation, and we hope to see like awesome products coming out.
Thank you so much. I just want to say that we need dozens and dozens of AGNITs in the country, so we can actually make a meaningful difference. Right? So I hope that many more people go down this path.
So being on that note, like I wanted to ask, like you were obviously a PhD student before, and then you did postdoc, so like long journey, and then now you're an entrepreneur. So how was the transition like for you as and what was the turning point where you felt that, okay, I want to make this into a startup? Like, could you talk about that?
Sure. Being a scientist and a researcher, I think that the part that excited me the most was the technology. So we had the technology, and as I said, we had published a lot of work, and we also had a few key patents in this area. And of course, the natural progression is, what can you do with it? What can I do more than publishing papers? What can I do next, right? And so there is this gap between, taking technology out into the real world. So you do have lab scale technology, but it's quite a different challenge to actually translate that into something that somebody will pay money to buy. And that's a pretty exciting phase to try and bridge, right? So that's where my motivation comes in. So having done the research part for 12 years now, so it was kind of a natural progression. So also it seemed to me that we have to do something about taking this technology out into the real world. So that's the reason that that I got involved with AGNIT. And it's been a fun journey so far. I have no trouble waking up in the morning and going to the office every day. So, so that's a sign. That's a good sign that things are going well. And at the end of the day, we all need a sense of purpose, and I think that this gives me a sense of purpose. So I'm able to do.
So what were like some of your like skills which you had to develop in the last 12 months is like as an entrepreneur, which you like, like what was the bridging gap skills, which, yeah, would you talk about that?
Oh, so many. I think if you talk to anybody who's doing a startup, they'll have pretty similar situations. So I don't know if I'm saying anything new, but starting from hiring people to raising money, following through with setting up protocols in place for various things. There are no systems when you start, right? So it's only when you start encountering issues that, oh, today I have to do something. I have to make sure that I filed all my taxes for the company, let's say, or I have to get another person to augment the team. So you're kind of wearing an HR hat, kind of a compliance hat. You're wearing a fundraiser hat, and it's all of those jobs, and people have to pull their weight along each of these different areas, and there are many calls on your time, and you have to prioritize. But at the same time, you also need to remember that at the end of the day, you're a deep tech startup, so your technology needs to be solid, right? So that's where I spend most of my time. And but at the same time, you do have to do all the other things in order to keep the lights on. So yeah, it's pretty exciting, and how you manage your time is pretty important.
Nice. So let me just like shift to the global scale of gallium nitride. Like, how is the global market for gallium nitride, and where do you see AGNIT in the next, let's just say, 5 years on that?
Sure. So the global market on gallium nitride is actually, rapidly advancing. And but I should point out that at the same time, it's a drop in the bucket when compared to the silicon market. So for these very same applications, by the way. So what we expect is that gallium nitride is going to eat a significant chunk of the silicon pie, so to speak, in the coming decade. So the opportunity size is very large. Right? And of course, there are established players who are working on gallium nitride and whose products are more mature, currently. And so you can buy some of these products already. Right? So this is a rapidly growing market, and everybody has a technology differentiator. So you can do things differently, right? But we should point out two things. Firstly, even in order to actually reach a kind of baseline standard in semiconductor technology is no mean feat, right? And secondly, the fact that, again, gallium nitride players are not competing with each other. They're competing with the silicon players at the end of the day. And so, as I said, the market is rapidly growing, and we also hope to be a significant player in this particular market. So we also have technology differentiators of AGNIT in and of itself, which is the reason that we believe that we'll be successful. But again, I should point out that the larger picture is that gallium nitride is huge, is a hugely growing market, and the competition is silicon, not other gallium nitride players.
Good point. Good point. So let me like come back to India, and the Indian government has been like proactively investing a lot of money in semiconductor fabrication, or like into like deep tech startups, like, and just to support the Atmanirbhar movement. And recently they also announced that there would be a PLI scheme for doing $10 billion dollar fabrication setup. So what does that mean for a company like AGNIT, or like other companies, as well as like, is there plans for AGNIT supporting other gallium nitride like ecosystem so that we can develop it more?
Sure. So I should point out that there's never been a more favorable environment to do anything related to semiconductors in India than there is now. So the schemes that have been announced are extremely critical to make sure that we actually get a foothold in this growing market, and it's a very important market. And that's something that actually we've also realized in terms of COVID, just the supply chain for some of these components, right? And what you would consider to be trivial, but not so high-tech components at the end of the day, right? So we are talking about things like driver ICs, for example, which is what there's a shortage of in the automotive market currently. So in a lot of these sense, it's probably the best time to actually start doing any kind of semiconductor work in the country. And I think that these schemes will go a long way in kind of attracting the right investment. And we keep talking about ecosystem, right? And in building that ecosystem, so which is very important, because at the end of the day, you want to make sure that you have as many parts of the value chain in the country as possible, so that you can have an end-to-end solution. So, the approach is very much kind of a make in India for India, and then you can make in India for the world sort of a situation. Right? So that's our approach. But we again the scale of investment required to make a fab, as we also discussed earlier, is quite large. So these incentives should really bridge the gap. So we are also eager to see what comes out of it. And whatever comes out of it, I think at the end of the day, we'll have a robust manufacturing ecosystem for semiconductors. It's absolutely a crucial technology in today's world, right? It's like the digital steel. It's like a country not having a steel industry. So, which is where we were at. But those things are going to change, hopefully. And I, for one, I'm looking forward to it.
We are looking forward to. So, as a last question, I know you have had a long journey and a lot of experiences, lots of ups and downs. Do you have a word of advice for young minds of this country who are looking seeing this interview of yours?
Not so much advice. I can talk about what worked for me, and then maybe they can draw their own conclusions. So I would say that what has worked for me is the fact that we really got neck deep into gallium nitride technology. So I would say specialization is very important, at least if you're doing anything related to tech. Mm-hmm. At the same time, once you have this sort of specialization, then you can take a step back and try and see if you can diversify into adjacent areas in order to try and broaden your skill base. But at the end of the day, there needs to be one thing that you're very good at.
Yeah.
Okay. And that would actually be the only piece of advice I want to give your viewers. So if anybody is watching this video for advice, because at least in terms of deep science and deep tech related startups and any kind of work that you want to do, you need a very good skill set in one particular area, and then hopefully you can build on the side, build adjacencies. For example, I had never hired anybody before I joined AGNIT, but that doesn't mean that I couldn't have done it. But if I didn't know gallium nitride, then I absolutely would not be here.
Mm-hmm.
So that's the only piece of advice I have to offer, actually. But otherwise, I would say, it's a fun journey. Don't be put off by all the hard work, and find what gives you a sense of purpose. And do it.
Yeah. There has to be a sense of fearlessness also, with sense of purpose mixed.
Right. Yeah. Absolutely. Yeah, absolutely. So find what excites you and do that. But make sure that you have the skills to do it in the first place. So you won't have all the skills, but it's very important to have to be highly skilled in one specific area at the very least.
Yeah, got it. Cool. Thank you so much for this interview. We are really honored for being able to interview you, and we're wishing.
Thank you so much, Nivedita. It's been a lot of fun. So thank you so much for interviewing me, and thank you for the opportunity to narrate AGNIT's story.
Yeah. Of course, pleasure is all mine, and we hope to see a lot of success coming from AGNIT hopefully soon. And thank you.
Thank you so much.